Okay, so this video is going to include the information for PVOD and Williams Syndrome. As I've started lately, we're going to focus only on the genetic information. And once more, if you have a question regarding anything else, please just send it my way, and I'll, address it and explain it. Um, so, in regards to PVOD first, the prevalence of PVOD is unknown due to misdiagnosis as idiopathic pulmonary arterial hypertension, meaning that once something is not officially diagnosed as PVOD, then it gets lost in the system under other statistics. So we don't really know the prevalence. We can assume knowing in theory, but not really. So we don't have um, a real number. And then you can see that we can assume that 20% of those with pulmonary hypertension actually have PVOD. Just remember, it's an assumption, okay? And if that is true, then the ratio would be 1 to 10 million worldwide, meaning that it's pretty rare still. We know that it's caused by mutations in the EIF2AK4 gene. It's inherited in an autosomal recessive pattern, meaning it has nothing to do with the sex chromosomes, meaning that in theory both sexes will have an equal chance of having the disease. But that's for the 2AK4 gene only. When it's caused due to mutation in other genes, the pattern is actually dominant, autosomal dominant. And as you remember by now and know by now, I hope, when it's recessive, you need 2 copies for someone to have the disease, meaning one from the father, one from the mother, most likely. And when it's dominant, 1 copy is enough to cause the disease usually. And then we usually see that one of the parents will be symptomatic to PAHTN. So we can talk about mutations in the bone morphogenic protein receptor 2. So it's actually affecting the receptor, okay, not the bone itself, abbreviated by BMPR2, have been identified in at least 50% of familiar cases, meaning that there's a family history here, and in 25% of sporadic cases, meaning that this somehow affects the disease that you have. And since this is a developmental disease affecting bone, the bones definitely can influence your ability to acquire and improve your skeletal motor and locomotion abilities and skills. We believe that, and this is part of the uniqueness of this condition, that the gene causes a problem in the translation of the information on the gene, but it's not known yet. It's not completely known and understood exactly how that happens. This means that there is no actual mutation that we can say, hey, it's a deletion, hey, it's an insertion, hey, it's a nonsense, and so or also so on and so forth. But it's believed to to occur during the translation phase of the whole process. And then the suspicion falls on the idea of some kind of shift in the reading frame shift. Once again, we're not 100% sure, but the gene is identified and there is a suspected cause or mechanism. It's also suspected to be inherited from the mother, causing a shorter protein to be produced. Once again, it's a suspicion. We don't have more information on it. So this is the part that is unique about PVOD, that while the gene is identified, the exact mechanism is not. I was not able to find an explanation for myself why they're suspecting the mother. When you say such a thing, the brain goes first to, wait a minute, so if that's what you suspect, it should be somehow related to sex chromosomes, but there's no evidence of that. So that's very interesting. It is divided equally between sexes, so I don't know. It's intriguing. We don't have all the answers as of yet. Now I want to continue with the specific genetic information for Williams syndrome. Also, very little to say here in compared to other conditions and syndromes that we've talked about. So, in regards to the Williams syndrome, it is caused by a deletion of genetic material from a specific region on chromosome 7, meaning that it's not related to the sex chromosomes. The deleted region, notice that we're talking about a region, okay? Includes between 26 to 28 genes. I want to stop and I want to say that again to correctly emphasize what we're talking about and what is unique about this syndrome. We have a whole region of a chromosome deleted, and with it we are deleting 26 to 28 genes. Notice that until now we are talking about mutations to 2, 3 genes, mostly one gene, maybe a variation of genes that cause the disease but a mutation only in one of them at the same time. Here we're talking about 20 up to 28 genes at the same time that are deleted. That's very, very unique. And then the vast majority of the genes deleted are believed to contribute to the wide range of symptoms and implications. I think that kind of makes sense. I mean, if you're deleting 28 genes, you're influencing 28 proteins that you should have had, and the symptoms will vary in accordance. So you see here several genes that are the genes that are typically deleted. For instance, the ELN gene is associated with connective tissue abnormalities and cardiovascular disease. Specifically, as you can see, the supravalvular aortic stenosis symptom. Then we see that deletions to CLIP2, GTF2I, GTF2I RD1, LIMP1, and perhaps other genes may explain the characteristics difficulties with the more visual or spatial tasks and unique behavioral characteristics and cognitive problems. And then we see that the GTF2I RD1 gene can contribute to distinctive facial features. What else? We can see that the presence or absence of NCF1 gene on chromosome 7 is related to the risk of hypertension. Actually, the loss of this gene, meaning when it does not exist, protects someone from hypertension. By the way, let's stop here and say, let's go 100 years forward or 200 years, God knows how many years, and say maybe we can get rid of hypertension just by knocking out this gene. You knock it out, the chances of hypertension go down. Obviously, we're talking here about genetic engineering, and it's not that easy, especially not ethically. No one has tried it yet completely, so we don't know if it completely would eradicate hypertension. And then the question is, would it eradicate even the ability to increase blood pressure under exercise conditions, for instance? If it does, then you are limiting your ability to exercise. If it doesn't, maybe it's a cure to hypertension. But if I had to bet my money or my life on something, I would bet that if you eradicate that gene, if you knock it out, you lose the ability to some extent or completely to elevate blood pressure, and then you have a problem with the system when high pressures are needed to function. We see that most of the cases are not inherited, meaning that they occur in random during the production of the reproductive cells, the eggs or the sperms. So family history, not a part of the diagnosis for this reason. It's considered an autosomal dominant condition because one copy is enough to create the syndrome. What else? And then in small percentage, people actually inherit the gene with the deleted sections or region from one of the parents. So that's all for week 7. Once more, always, if you have any questions on how to interpret the information, something that is misunderstood, please reach out to me and let me know, and I'll answer your questions. Have a good one.